So we're going to say this dot player dot map equals, I'm going to use the blitmath class again. Replace values from multi-array method. Okay, so it wants to know the array that we're going to replace values from is this.player.map, and it's going to make a clone of that array. Okay, then it needs to get past an array of the values to take out. So we're going to take out 1250, which represents a spike. 923 represents an ending spot. 7777 can be a coin spot. Also 525 can be a coin spot. So we want those taken out of the player's map so it can walk past them. Okay. Let me save it. Okay, and now it's walking past those values. Okay. What we want to do now, let's cut this and put this down here, is instead of drawing these values, well, except for 923 is going to get drawn in just that the player can walk through it. But instead of drawing the coins and the spikes, we're going to place them as their own canvas animations and travelers. Okay, the spikes will be travelers that have a canvas animation, and the coins will just be a canvas animation in their spot. Okay, so to do that, let's set up some vars. I'm going to say var coins and var spikes to hold the coins and spikes. Let's copy this and say, let's make another var up here. Var don't draws. Okay, we wanted to draw 923, so it's just these three for now. So we can just reuse don't draws array. Okay, so we'll say this has a property called ignored arrays, which means the arrays do not draw. So we could say don't draws for that. Okay, so here when it's drawing the map, it's not going to draw those, and also the player walks past them. So it'll be that they're not there, but we're going to use them here. Function assignments also equals don't draws. Okay, and then we can call dispatch function assignments. Okay, we're going to give it a reference to this class, which is going to have the level setup method, and also this class is a event dispatcher, so we can pass, that's what it wants there, which is also this class. And we're dispatching function assignments for the level 1 map at 16 by 16. Okay, so what this method does is every time it finds one of the don't draws values, 1250, 77, or 525, each time it sees one of those values inside of the level 1 map, is going to make this function fire with an event that has all of the tile properties inside of it. Okay, so inside of level setup, which is the method it will cause to happen, this will get an E event, which is a pattern action event that will be passed to it. So for example, to place coins, we'll say if this dot values match, which is just a generic method that matches two arrays, 25, and e dot tile value. So if the tile value is 525 or 7777, it's a coin to be placed. Okay, so a coin is going to be a canvas animation. This dot image is the source. It's going to draw onto car layer, and you pass null for the rectangle. Its position now is e.x, so the event also has the position of where the tile is, and so we put it there by just saying e.x and e.y. The width and height is 16 by 16. Okay, so that's a coin, and let's define an animation for it. Define animation, and call it spin because it's going to spin. Okay, and the XY indexes for that are 25, 5, 26, 5, 27, 5, and 28, 5. Okay. The canvas animation for the spin animation will be copying from the sprite sheet one frame at a time and displaying it. Okay, so we also need to say coin.current animation equals spin. So that puts it on spin to be displayed. And then we'll say coins, or coins array dot push coin. Okay. For I is less than coins dot length. Okay, so each coin is a canvas animation. Let's make a var to reference it. Cn. So Cn equals coins I. And we'll say Cn dot animate 0.2 just to animate it slower. And then Cn dot blit to display it. Animate progresses the animation. Blit displays the coin at its X and Y location. Okay, so now if we save it, we should see the coins animating. Okay, there we go. You can walk past them. Okay. Okay, so next, if we want to collect a coin, we'll use a different class now to help us collect the coins, to help us do basic proximity collision detection between the player and the coin. Say geometric math dot test for point in circle. Okay, so the player's position underscore pos is the player's position, its X and Y location. We want to test in a circle radius of 24, so a 24 radius circle. And the point that we want to test, if it's inside of the player's 24 by circle position, is going to be the coin's position. So for that, we say get position, the get position method that the coin has. Okay, so if that test is true, if that's true, so to take it out from being displayed and animated, we will just take it out of the coins array. And geometric math has a splice function that splices an array without doing anything else, doesn't return anything. Okay, and then we'd have to break so that it starts over, because we're using the length right here. Just our point and circle. CN. So now when we save it and run it, you'll also collect the coins that he's close to. Okay, we don't even see the spikes now. It's like they're not there, even though they're there in the map. Okay, so next let's put the spikes there.